The topic for today is graphs of linear equations with two variables. And the first thing that we're going to start with is the coordinate plane and identifying the parts of the coordinate plane. So first of all, on our coordinate plane, and you've worked with this before, this point right here where the axes cross is the point 0, 0. And it is also called the origin. And the coordinate plane is divided into 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And they are identified in Roman numerals. And what we're going to do is identify the sign of x and y in each quadrant. So in quadrant 1, x and y are both positive. In quadrant 2, x is negative, but the y coordinate is positive. In quadrant 3, both the x and y coordinates are negative. And finally, in quadrant 4, the x coordinate is positive, but the y coordinate is negative. All right, the first thing we're going to talk about here is intercepts. And we'll start with a y-intercept, and then we'll move to x-intercepts. What a y-intercept is any point where a graph crosses the y-axis. And it doesn't have to just be a line, it can be any shape. A y-intercept is just a point where the graph crosses the y-axis. And you can see that right here in this graph. This is the y-intercept. And in this case, it is the point 0, 4. That's the y-intercept in this particular example. In the graph, it's where it intercepts the y-axis, where it crosses the y-axis. Now, because all y-intercepts are on the y-axis, all y-intercepts have these coordinates. The x-coordinate is 0, and the y-coordinate is the number where the graph crosses. So all y-intercepts look like this. All right? So here's what we're going to do. We are going to find the y-intercept of each line. And we're going to do this using algebra. Here's what we know. The y-intercept is the point 0 and then a number. Well, the 0 is the x value. So what we're going to do is plug x equals 0 into this equation and solve for y. So I have 2 times 0 plus 4y equals negative 3. So this is 4y equals negative 3. Divide both sides by 4. And y is negative 3/4. So the y-intercept is 0, negative 3/4. That's how we find the y-intercept. All right, let's go to the next example. Same thing. We know that the y-intercept is the point 0, comma, and then a number. The 0 is the x value, so we're going to plug 0 in for x and solve for y. So I have y equals 1/2 times 0 minus 6, which gives us y equals negative 6. So 0, negative 6 is the y-intercept. And this would be how you find the y-intercept for any graph. Not just the line, but any graph. You're going to plug in 0 for x and then solve for y. We're also going to find x-intercepts. And an x-intercept is any point where a graph crosses the x-axis. And in our graph, that's right here. And in this case, This is the point 2, 0. Because all x-intercepts are on the x-axis, all x-intercepts have the coordinates, a number, and then 0. So the y is 0. And so for that reason, it makes it really easy to find x-intercepts. And we're going to do that in each of these two examples. So what we're going to do, our x-intercept is the point something, 0. Remember, that y is what is 0. So we're going to plug y equals 0 into this equation and solve. So I have x plus 3 times 0 equals 5, gives me x equals 5, and the x-intercept is the point 5, 0. In the second example, I know my x-intercept is going to be the point something, 0. And this is a y value, that is 0. So I'm going to plug y equals 0 into this equation and solve for x. So add 2 to both sides. And I have 2 equals 3x. Divide both sides by 3. X equals 2/3. So that's how I find y-intercepts and x-intercepts. All right, that's going to help to set us up for our next task, which is graphing lines. So the graph of a linear equation is a line, a straight line, and each line is made up of all the points or ordered pairs that satisfy the linear equation. And remember, we said the number of points or ordered pairs on any line is infinite in number. Fortunately, in order to draw the line, we only need 2 points. So if we can find 2 points on the line, we can then put a ruler down and draw a line through those 2 points. So I'm going to show you 2 methods for graphing a linear equation. And this is the first one, and I just call it method number 1 because it's the first one I'm going to show you. And that is to identify any 2 points on that line. To identify a point, choose any value for x, plug that value for x into the linear equation and solve for y. The values for x and y become the coordinate x comma y on your graph. Do this for each of your 2 points. All right? Note, often the easiest points to find are the x-intercept and the y-intercept. And once I find those, I'm simply going to draw a line through the 2 points. So what I'm going to do first here, I've got an example to graph, and I'm going to find my x-intercept and my y-intercept. Here's my y-intercept. It is the point 0 and a number. So I'm going to put 0 in for x. So I have 2 times 0 minus y equals 6, which gives me negative y equals 6. Divide both sides by negative 1, and it gives me y equals negative 6. So 0, negative 6 is my y-intercept. And I'm going to graph that, and it's right here. Next thing I'm going to do, find my x-intercept. This is the point, some number, and then 0. So I'm going to plug in 0 for y. This is 2x minus 0 equals 6, which gives me 2x equals 6. Divide both sides by 2, and I have x equals 3. So this is the point 3, 0. Where that is on the graph is here. Now I have 2 points. That's all I need to graph a line. So I'm going to put down my ruler, and I'm not merely going to connect the points. That would be incorrect. If I just connect the points, that's a line segment, not a line. I'm going to draw a line that goes through on both sides, and I'm going to draw arrows on the end to indicate that it continues indefinitely in both directions. All right, let's try the next one. Now, keep in mind, I have to find 2 points. I can either find the x-intercept and the y-intercept, or any 2 points that I want. All right? So, for example, let's say I want to find this point. I'm going to put 2 in for x. Why? No reason, just picking 2. So I have 3 times 2 minus y equals 5, which gives me 6 minus y equals 5. Subtract 6 from both sides. I have negative y equals negative 1. Divide both sides by negative 1, and that gives me y equals positive 1. So I have the point 2, 1, and I'm going to graph that. All right, I can do this again for some other point. I can choose an x-intercept or a y-intercept or any other point that I want. How about this? Let's put in negative 3 and see how that comes out. So I'm putting negative 3 in. This is my x value. So I've got 3 times negative 3 minus y equals 5. This is negative 9 minus y equals 5. Add 9 to both sides. And I have negative y equals 14. Divide both sides by negative 1, and I have y equals negative 14. Now this particular one is way off my graph. And I'm not particularly a fan of having a number way off my graph. So here's what I'm going to do. I'm going to not use it, and I'm going to find a different one. So here's what I'm going to do. I'm going to find the y-intercept. Because what I know is that negative 3, negative 14 is way off the bottom of my page on the left-hand side of the y-axis. So maybe it crosses my y-axis around here. So I'm going to find another point, and I'm going to make it my y-intercept. So 0, comma, a number. And I have 3 times 0 minus y equals 5, which gives me negative y equals 5. Divide both sides by negative 1, and I have y equals negative 5. So 0, negative 5, and that is on my graph, which is so much easier to work with. So this time, I just didn't choose wisely, so I had to find 3 points, so I had something on my graph. And now I can draw my line. So put my ruler here. Draw a line that goes through both points, and draw arrows on the end to indicate that it goes indefinitely in both directions. All right, there is a second method for graphing a linear equation, and that is to do this. Rewrite the equation in slope-intercept form, y equals mx plus b. You know how to do this because you've been practicing it since class on Friday. The point 0b is the y-intercept. So we're going to find that and graph that point. M is the slope. We're going to write m as a fraction, and since m, the slope, is rise over run, we're going to place our pencil on the y-intercept point, move your pencil up the number of units of rise, or down if the slope is negative. Then move your pencil the number of units of run to the right and draw a second point. Now, again, you're going to use a ruler and draw a line through the 2 points. So let's do an example. This one is already written in the form y equals mx plus b. this number right here is our B. So my y-intercept is the point 0, 4. And I'm going to graph that right here. All right, my slope, which equals m, is negative 1/3. Now remember, this is the rise, this is the run. Now it's negative, so from this y-intercept, I'm not going to go up 1, I'm going to go down 1 to here. And then I'm going to go 3 to the right. I always go to the right. If it's positive, I go up. If it's negative, I go down, but always to the right. So 1, 2, 3 to the right, and put another point. And now I'm going to use my ruler and draw a line through these 2 points. All right, let's go to a second example. This one is not written in slope-intercept form. So our first task will be to do that, to write it in slope-intercept form. So the first thing I want to do, get 5x to the other side by subtracting 5x on both sides. So I have negative 2y equals negative 5x plus 6. And I need y by itself, so I'm dividing everything by negative 2. So I have y equals positive 5/2x minus 3. So the first thing, this tells me that my y-intercept is 0, negative 3. So I'm going to graph that. Now my slope m is 5/2. Remember, the 5 is the rise, the 2 is the run. This is positive, so I'm going to go up and then to the right. So I'm going to go up 5. 1, 2, 3, 4, 5, and 2 to the right, and I'm going to put another point. And now I'm going to connect those with a line. Put arrows on the end so we know it goes infinitely in both directions. Now the next thing that comes up is horizontal and vertical lines. And this is particularly interesting because horizontal and vertical lines, the equations look completely different. So you can tell if you're going to have a horizontal or vertical line simply by looking at an equation. For a horizontal line, you're going to have an equation that says y equals, and this is a number. In other words, there are no x's in the equation. No x's in the equation. If you have a line like that, it's a horizontal line. And this is something that you just need to remember. So we're going to graph a few of these. You can see some on the graph here. Y equals 2 is a horizontal line that goes through 2 on the y-axis. Y equals negative 4 is a horizontal line that goes through negative 4 on the y-axis. So y equals 5 goes through 5 on the y-axis, and I'll draw that. Y equals 0 goes through 0 on the y-axis, so it actually is the x-axis. And I'll draw a line through that and put arrows indicating it goes infinitely in both directions. So those are horizontal lines. They take a lot less work, but you have to remember what they are. Now, vertical lines have a similar situation, but the opposite situation. So with a vertical line, its equation has x equals a number, and there are no y's in the equation. These are vertical lines. So here I have x equals -6. It goes through -6 on the x-axis. X equals 3 goes through 3 on the x-axis. X equals -4 goes through -4 on the x-axis. And x equals 0 goes through 0 on the x-axis. So a lot easier to graph, but at the same time you've got to remember what to do with horizontal and vertical lines and how to identify them. And you identify them because they're either missing an x or they're missing a y. All right, the last thing we're going to do is we're going to graph a line if we're given certain information about the line. Now, in this situation, we're given a point on the line and the slope of the line. If we're given those two pieces of information, we can graph this. In our second method of graphing a line, we used something just like this. So it says graph the line that has a slope of -3/2 and passes through the point -4, 1. First thing I'm going to do, start at the point -4, 1. And that is here. Now, -3/2 means rise over run. Since it's negative, it's going to be 3 down. It always goes to the right. So you're going to go down 3, and you're going to go 2 to the right. And we're going to use a ruler to draw our line. Now you may ask, what if you get a slope that looks like this? What if slope is 2?
2 over 1.
Make it 2 over 1. Now you have a rise and you have a run. And so you're able to graph the slope of this particular line.